see if this works. It does. Hi, everyone. I must admit my Chinese is not so good, so I'll just stay on the English side of things. As stated, my name is Mark. I'm from Patricia Blockchain Foundation, or Patricia. A bit about what I want to talk about today, and it kind of extends very nicely from the Humanity Project. I kind of brought a bit of understanding of what we do, and then I really took cases in that kind of states what can be done if we look at identity, we look at privacy, and we look at how we actually utilize something like Web3 in a larger enterprise setting at the same time. But mainly, first of all, just a bit quickly about what we're actually doing. So we're kind of combining two things. When we started out building a blockchain 6-7 years ago, we were actually looking at utilizing something like multi-party computation a bit beyond the classical means of saying, let's do some multi-sig stuff, right? We actually want to be able to utilize private information or that non-public data, being able to utilize that in an encrypted fashion and actually have something where we can do more with data. I think there was a very great presentation just a bit early on that. And the second thing, when you use and understand this about privacy, then you also have the capability of proving what is actually being done with data, right? So if I do something on top of encrypted data, I should also be able to ask the question, when was it done? Who and why, right? And I need provability of that. So that's really the combination here. Running this as a generalized information scheme that is a blockchain that have MPC built in, right? See if it works. It does. So you can kind of see three capabilities of this, right? Interoperability and this understanding of we want to connect both enterprise information and these number of public blockchains together. So we have more utilization of data in general, right? Then we can talk scalability. Yes, fine, we can scale. Everyone can scale on blockchain. And then we have the privacy piece, right? This informational interoperability of data now being shipped everywhere that you can actually do computations upon. That's right. So what we're actually kind of stating is, in the world we live in when we look at Web3, right? I can go with my chain saying everyone should be on Patricia blockchain. But in reality, when we look at enterprises, we look at the work that's been going on, especially in Japan and Asia, but also slowly into Europe is, well, there's a lot of chains, right? Both private and public, and we need a way of interconnecting them, right? And when we interconnect, we have a lot of data, and we need to take care of the privacy and the security of that information. So what we're really stating here is, by utilizing part of these protocols, that is something like multi-party computation or fully homomorphic encryption, you would actually be able to practically have a system where anyone on any chain could subscribe to data on any other chain and actually have data replication happening between it. By really stating that, you're looking at actually creating interoperability between networks. And when you actually do data replication between different consensus protocols and different means of storing data and utilizing data, you need provability of that privacy haven't been breached and the data is correctly moved. So what you really look at here is a system that states I'm sitting on an Ethereum chain, I write some type of transaction, I interconnect it to subscribe to a different chain, potentially with a different consensus, in which I now have more data being shipped towards me, right? So it's a purely subscription model you have here, right? And the need for this then comes back to stating that what you're actually able to allow yourself to look at is having way more data, right? That informational space you saw earlier, there's a lot of non-public data or data that is placed somewhere. I really can't get a hold of it, but now I'm able to subscribe towards it, right? I'm able to utilize this data and work with this data, right? And this network here is then the provability of when data is replicated, it is provable replicated. That means I can guarantee that data comes with the right type of consensus, right type of encryption, and right type of privacy. Yes. But what is really interesting, for me at least, is what does this mean? Right. So I brought a few cases here. On your, that must be your left side over here, we have the proof of identity with private data. You just heard humanity stating, you know, here's face printing, right? That could be brilliant to have that, or here's handprints. But when we look at places like Europe, for instance, Europe currently is implementing a large regulation called the IDAS 2 regulation that states by the end of 2026, every single European country needs to provide a digital wallet for all citizens. And every single citizen needs to be able to take this digital wallet and travel anywhere in Europe and present information about themselves that can be verified. That means, well, practically, I am getting verifiable credentials to a wallet I have that I can go, I live in Denmark normally, I can go to Germany and actually present to a bank my KYC information. And they are required to be able to verify this information and use it. That means we're already in a state where we look at what is privacy really here, right? From a European regulation, we have GDPR. GDPR states, you know, you as a single enterprise or something else, you're not allowed to just keep my data in the open. You're actually not even allowed to utilize my data without me having consented upon it very specifically. So in this state, we have multiple challenges that need to be solved. One is they need to be able to verify information, guarantee that this information is only used by the consent of me. That kind of goes back to having some type of ledger, some type of qualified ledger, as IDAS is calling it today. And on top of that, also be able to guarantee that the data is stored securely and fully protected, right? So now we're into the data and privacy protection aspect, right? Whether that is multi-party computation or something else in between, that's fine. The second part is a system running in Switzerland today. So this is interoperability of identities. So even though somewhere like Europe defines we all need a digital identity, there's no definition of one format for all identities. I can have 10 countries with 10 different formats of a digital identity, but the requirement that I should be able to travel anywhere in these 10 countries and actually present my identity to have it verified. That means now we look at interoperability and we look at actually having systems that are able to take one format, transfer it to a different format without ever breaching the privacy. So normally you would solve that by having a trusted entity. And I think most of us kind of hears this trusted entity and state, okay, so I need somewhere where I can place an encrypted part of my identity. I could decrypt it, and this entity will encrypt it and sign it and give it back to me again. So now we're actually at a point where my privacy is potentially leaked. So systems like this is actually defining that we need structures where we're able to do this, well, provable. We need to be able to verify that when I actually move my identity between formats, I can do it encrypted, and I can do it with signing on top of that. That means I can prove that it has been done, and nobody actually saw anything. So big part of this privacy aspect also in Web3 and also this issuing of credential needs to come with provability of everything, right? Another place where this is going on is if you look at Japan currently. Japan is writing a new regulation on AML. I think all of us here knows AML can be tricky, and we have kind of the classical banking system on one side. So I come from banking myself, and a lot of work goes into understanding that if you need AML in a system like Japan or a system like Europe, there is a lot of data that needs to stay encrypted when you do fraud analytics or trying to build what is called fraud detection map. So you need a system to operate on top of encrypted data to predict behavior. For a single bank, that's mainly not a problem. That can be done fairly simply, right? What becomes a challenge is that most fraud actually comes between the transaction of two or more banks, right? So now I need systems for interconnecting banks with private identities on top of transaction and actually build fraud prediction models. So here you utilize an enterprise system, a Web3 system, for instance, to actually connect the banks, let them secretly share encrypted information, and building protocols on top of that. When you then connect that to new AML regulation, especially going into Japan, Japan states today that currently they expect all AML regulation on top of kind of the crypto world, as we call it over here, to be just the same as in classical banking. So now I actually need to have a system that can start breaching these two behaviors. I need a way of being able to look at transactions on blockchains and on exchanges with identity information on top of that. That means you need a privacy-preserved computation to happen on top of blockchain and standardized real-world classical banking systems. So it becomes AML as a commodity, right? It's a combination of our identity, encrypted information, and something like a privacy-enhanced technology to do this computation. So you can start building fraud detection map that bridges multiple banks, multiple exchanges, and the classical crypto world we know so well. The last one is a bit more tricky, a bit of a busy slide. But when we look at all of this and we look at this relationship between being able to have a lot of data and actually utilize this data, you need a different way of doing it. This case here is an interesting case of I own a car. I would like to create a reselling market, right? So it's a used car. And how can I actually have a real value to that car based on behavior? So it's quite easy for me to buy a Toyota somewhere, right? Matches towards the market state, well, it's around 6 years old, no incidents, this is the price. But what actually becomes interesting when you look at places like Europe is stating, well, a real car and the value of a car is more than just what is the price of the current market. It's the behavior of how I drive. I'm a maniac when driving, right? So I had maybe a lot of incidents, maybe tried to fix my car myself. Maybe I drive always in sports mode, right? So I'm actually devaluing my car quicker. But that is not something that's normally available for a single car provider. So here, it's actually a combination of systems. For Europe, every new car built today is actually built with a black box inside. A black box that tracks information about the car itself, that tracks information about behavior, incidents, and everything else. So for actually having a transparent market, you would have something like an NFT representing a single car, but connected to a value that's calculated on top of private information, right? On top of that behavior that you see in the market. That means that NFT suddenly have calculations and prices being set from a multiple of car provider that actually contains a lot of this private information that is normally shipped to the company. But the company itself is not allowed to look at it in a decrypted fashion, but I want the real value of the car. So here they utilize this behavior of actually operating on top of encrypted data, calculating the price based on behavior and the market value, and actually placing that transparently inside the NFT. So the NFT is now having a relationship directly to the car, and thereby you can interact and actually have a real reselling market, right? So in general, what we look at here is an environment where private information should be utilized, but should be utilized in a way where you can prove that I'm never in breach, I've never done something I shouldn't, and rather I can give transparency of that information. And the last one, here's an example of actually building what is called a CBDC, right? CBDC for the Red Cross, saying I have refugees in refugee camps. If I give all of you cash in a refugee camp, the risk of actually being murdered or struck down is very high. So maybe I should give you privacy. I should give you a digitalized token that have your privacy in mind. And this is just some of the cases that can be done. Thank you very much.